the shape of the charge and discharge curves for Na3D2, PO4, 2F3 reveal the underlying redox behavior of the vanadium ions? And what do the observed voltage plateaus suggest about the electrochemical reaction mechanisms taking place in the material? In what ways might variations in the slopes and plateaus of these curves indicate the efficiency of sodium ion intercalation and deintercalation within the crystal framework? And how can these features be correlated with the theoretical capacity of the cathode? Can Davis-Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What insights do the initial charge and discharge profiles provide regarding the kinetic properties of the electrode, such as ion diffusion rates and charge transfer resistance? And how might these be affected by structural factors inherent in the Nasicon-type framework of Na3D2, PO4, 2F3? How does the presence or absence of hysteresis between the charge and discharge cycles inform us about the reversibility and potential energy losses within the battery system? And what role does this play in determining the overall cycling stability and long-term performance of the cathode? What additional analyses, such as electrochemical impedance spectroscopy or cyclic voltammetry, could be integrated with the interpretation of these curves to further elucidate the mechanisms of sodium storage and to identify possible degradation pathways? In exploring these questions, how can we better understand the interplay between the crystalline structure, the redox activity of vanadium, and the resultant electrochemical behavior as reflected in the charge and discharge curves of Na3D2, PO4, 2F3, and what future experimental modifications could be implemented to optimize both the capacity and cycle life of this promising cathode material? How does the fluoride ion doping in Na2Fe PO4F contribute to the formation of its two-dimensional layered structure, and in what ways do these layers facilitate the storage and shuttle of sodium ions between the Fe PO4F sheets? How are the FeO4F2 octahedra arranged with co-edged and coangular connections in this material, and how might the specific geometric configuration enhance the kinetics of sodium ion intercalation and deintercalation? When carbon coating is applied to Na2Fe PO4F for use as a cathode, how does the resulting improvement in electronic conductivity relate to the observed average working voltage of approximately 3.0 V and a reversible specific capacity of 110 milliamperes Hg superscript 1, which corresponds to about 90% of the theoretical capacity of the Fe superscript 2/Fe superscript 3 redox couple? What does the appearance of two distinct voltage platforms at 3.06 V and 291 V in the charge/discharge curves indicate about the degree of material polarization and the efficiency of the sodium ion transport pathways in the system? What?